All right, in this video, I'm going to be going through the next section of the review that is for standard or indicator 4.1 on simplifying. So it's going to be questions 6 through 10. All right, question number 6, I want you to simplify a fraction. So what I'm going to be looking to do is see if I can divide these two pieces together, this first term from the numerator and this denominator, and then I'm going to see if I can divide the second term from the numerator also with the denominator. Now, if it helps you, you are more than welcome to rewrite this as two separate fractions, right? You are welcome to do this. You can do this with any fractions, just split it up, the same denominator in both cases, and that might help you remember, oh, this denominator goes with both of those pieces. All right, so starting on the first term here, 2 divided by 2 is 1. I'm not going to generally write it unless I have to. I have 5 x's, so x to the 5th. I'm going to remove one of them, so that's going to be x to the 4th here, plus, and the y's already canceled, so I know that part. 4 divided by 2 is 2, no more x's. Y to the 6th, I'm going to divide out one y, that's going to be y to the 5th. So that is my final answer for number 6 to simplify. Number 7 to simplify. All right, I need to do order of operations. So powers first. We're going to do 3 squared, which is 9. X to the negative 2 squared is going to be x to the negative 4th. And that's going to be y squared. We're going to keep the y to the 7th. And then 3x to the 5th, y to the negative 3rd. Now, I am not a huge fan of this piece that has a negative exponent. I don't like the fact that that piece has a negative exponent. So I'm going to move them. Right, just move those terms. The 9 stays, the y squared stays, the y to the 7th stays. This x to the negative 4th is going to go to the denominator. All right, so 3x to the 5th. All right, there's all the positive stuff. All right, all the stuff that isn't changing. So let's see, x to the negative 4th, we're going to move that down here. When it moves, it becomes positive, meaning the exponent becomes positive. And then this y to the negative 3rd that's in the denominator, we're going to pop that up to the numerator. And again, we're going to make that one positive. So let's see what we got here. 9 divided by 3 is 3. All of the y's are now in the numerator. And if I add them all up, that's going to be y to the 12th. All of the x's are in the denominator. And if I add those up, that's x to the 9th. That is a horrible 9. Let's try that again. Slightly better. All right, so there's the final answer for number 7. Simplified. All right, moving right along. Oofed. Okay. Problem number 8 is going to take a little bit of work here. We need a common denominator, and the common denominator, and I'm going to put this off to the side because I know how large I write. The common denominator here is k plus 2 times k plus 3. So this first fraction has the k plus 2. It is missing k plus 3. So that means I'm going to need to take this times k plus 3 and this times k plus 3. All right, cool. So that numerator, distribute. We're going to get 5k times k, so 5k squared. And then 5k times 3 is going to be plus 15k. Yes, all right. So that's the first fraction. Now, if I take a look at the second fraction, well, I've got a plus sign between those, so let's go ahead and drop that plus sign here. And then I've got k to the 3rd, which, all right, cool, that's part of the common denominator. I am missing the k plus 2. So that means I'm going to take this times k plus 2. That creates the common denominator. But then I got to take that whole numerator times k plus 2. Now, the difference is this one on the left side was simple distributive. This is the more complicated distributive. Still distributive property, but you've got to do full distributive property. Okay, so make sure you're doing that. So let's see what we got here. We've got k times k, so k squared. K times 2 is going to be plus 2k. Negative 4 times k, so minus 4k, rounded over fraction. I'll have to fix that in a second. And then negative 4 times 2 is going to, whoops, that's going to be negative 8. All right, so I ran out of the fraction bar over here. There we go. So for that numerator, I would like to combine any and all like terms and just clean it up in general. So let's see what I've got. I've got 5k squared plus a k squared. That is going to be 6k squared. 15k plus 2k is 17k. 17k minus 4k is going to be 13. So plus 13k. And the random negative 8 at the end, so minus 8. all over. You do not need to multiply out the denominator. In fact, I would encourage you not to. So we've got 16k squared plus 13k minus 8. All right, cool. And problem number 8 is done. Moving right along. Ooh, this is honestly one of my favorites because basically you just, I'm saying just, but you need to factor and then see what can cancel out. So, x squared plus 3x minus 10. I'm going to actually go ahead and put these above the pieces that I'm factoring here. So let's see, we're going to split the x. I'm going to split 10 using 5 and 2 to make a positive 3. We'll make the 5 positive, 2 negative. Underneath it, x squared minus 4. That's going to be a difference of perfect squares. So x splits, 4 splits, make 1 positive, make 1 negative. Order doesn't matter on those. X squared minus 2x minus 8. So split the x. We're going to go 4 and 2 for the 8. Make the 4 negative and make the 2 positive. Yep. And x squared plus 2x minus 15. All right. Split the x. Let's go 5 and 3 for the 15. Make the 5 positive, make the 3 negative. All right. Now, once you've done all your factoring, love this because what you're going to do is come through and look for any factor that you have in the numerator that also appears in the denominator and cancel it out, right? Divide it out completely. So the x plus 5 here can take out the x plus 5 there. Let's see, x minus 2 will take out x minus 2. I do not have an x minus 4 in the denominator, so that's got to stay. But that x plus 2 can take out that x plus 2. So that's gone, and all that's left is, well, in the numerator, x minus 4, and then in the denominator, x minus 3. That is your final answer for that simplification. All right, number 9's done. Let's see what number 10 asks you to do. All right, so number 10, you need to break up or break down these radicals. So off to the side here, let's break up a 20. So that's going to be 2 and 10, 2 and 5. So 2, 2, and 5. So that's 2 root 5. I'm going to do the same thing for 45. So 45, 5 and 9, 3 and, that is a horrible 3. There we go, 3 and 3. Started writing that way too fast and it did not work well. So that's going to be 3 root 5. Okay. So now the 8 sitting here and the 3 sitting here, you're just multiplying those with those roots. So we're going to do 8 times, well, root 20 turned into 2 root 5. That's going to be 2 root 5. Plus 3 times 3 root 5 for the 45. So 3 root 5. So let's see, 8 times 2 makes 16 root 5. 3 times 3 is 9 root 5. And because these are both root 5s, yes, you can, in fact, go ahead and add them together. So 16 plus 9 is, what is that, 25 root 5? All right, so that one's good. And last one, the part B for number 10. This is straight, just follow order of operations. So I'm going to do negative 3. Inside the parentheses, 4 minus 8 is negative 4. These two powers at the end, I can do both of them. They don't affect each other. So 2 to the 0 is 1. 4 squared is 16. Negative 3 times negative 4 is 12 minus 1 plus 16. Let's see what we got here. 12 minus 1 is 11. 11 plus 16 is 27. 27 it is. All right, so that's the end of the bits, parts, and pieces there for section, for indicator 4.1. Come on back and we'll do the next one in the next video. Let me know if you have any questions or concerns.